Now coming down to your design of your actual robot that you've got to build, you've got to start thinking about some pretty basic design principles. I'll just begin with a revolute joint. So your main revolute joint, if you want to build your robot this way, will be your base. Base has a revolute joint. I always suggest using a turret. As I said before, the motors have a bit of slop in them. So that error accumulates over each link that you build up. But if you add a gear ratio in, essentially you minimize that error of that slot and you maximize the number of encoder counts you get per revolution of this guy. So I strongly recommend using the turret in your design. We'll show you a simpler way to use the turret later. But yeah, that's something to think about. Secondly, if you wanted to make a prismatic joint, we've got rack and pinion gears available, and this will make the prismatic part of things a lot easier. So this is an example of how to use them. Put them along one of these bricks, techno bricks. Clip it along, they just clip into place. They make a nice little rack there, and then a gear can go along them quite well. So the gears slot straight in there. Again, this will reduce your, the smaller this gear, the more encoder counts you get, the higher the resolution of the robot. Obviously trading off speed if you do that. So yeah, there are a couple of design principles you should think about when you want to build your robot. The use of the turret, rack and pinion for a prismatic, or you can just use straight off your motors as your revolute joints. It's up to you really. We'll give you some examples of those later on. Just wanted to show you guys the difference between the connecting pins in Lego. Most people overlook this. The darker pins, the black pins, have a lot of friction. They're very good for joining two pieces together, but if you want a spinning mechanism, they're not the greatest. They've got a lot of friction in there, stops it from spinning, but if you double it up, they're quite hard to pull apart comparative to the other pins. When you go to a lighter pin, this guy's got a star section to go into a star bit. You've got a lighter section. They're made a lighter pin. They're made a lot better. They can spin a lot easier. So if you've got spinning parts or you've got a spinning node in your construction, try and use a lighter pin. That'll make it more efficient for the motors or whatever has to turn that piece. Just wanted to give you some quick examples on how to make some good connections in Lego. Most people overlook this. Lego is only ABS plastic. It's not indestructible, and it bends a lot when it's in when it's got a bit of a load applied to it. When you guys are building your robots, you're going to be building a long arm. If you're building a prismatic, you will be as well. So you just got to think about some things. So when you pin together a joint, just to give you an example, see like that. It's a good joint, looks good, but as soon as you apply some kind of weight to it, it really flexes out a fair bit. Not too good if you want to keep things accurate or if you've got swinging arms. Just a quick way of doing it. If you bring it back one or two pins preferably like that, you gain a whole heap of strength in your build. Again, on top of that, you'll notice that this is in single shear. This is a pretty bad design for an arm, a boom. So you can replace that. If you get rid of these pins, you can get a double shear pin. So these, it goes through two blocks. So if you place it in the end like that, let's do, get your next arm, place it through like that, you still got another point again. So now this is in double shear. You get a whole heap more strength, you get flexibility, got a nice long boom. You can do this for a long distance. If you think about it right, so there's some things to keep in mind, especially just keeping the strength in your arm will make your life a lot easier. Your robot won't break if it goes too fast. And we'll show you some examples of how to get good reach out of your robot later on. Just wanted to show you how to make a holder for a pen or a pencil for your robot. This is a pretty heavily overlooked part of your robot. I'll show you how to make a really sturdy pen holder so you won't run into any trouble. Firstly, the pen's going to sit along this piece. I selected this piece because of the L bend in there. Gives you a bit of room to attach it to the rest of your robot once we're done building this. So the pen will sit along this face there, like that. Sorry for that. So like that. We're going to build a clamp to hold that there, actuated by this rubber band. So to begin, grab some axles of length 3 and 4, thread them through this connector. One's even, one's not. Okay, get your double length pin, so double shear pin through the bottom there. Throw on one of the 3 lengths, and then thread this guy through like that, and clip the other guy on the other side. Simple little mechanism. You can start to see how it might start to work. Finishing off, thread the number 5 axle through the 3rd hole, like so. Jump it on. A little bit fiddly at this stage, nothing too major. Finish it off by putting the rest of these on. So you can see that's the mechanism, the clamping mechanism. We just got to thread the rubber band on there. I think it's about 2 turns or 3 turns of this red one to get it to work properly. Yeah, so it's 3. And then we can put the pen through. So now it's self-actuating. Quite handy. Put the pen through, let it go. Holds the pen perfectly, and it's all ready to be put onto your robot. So you can attach your arm however your last link is, if it's prismatic or if it's rotational. You can attach straight onto this face. You can also replace this guy with whatever suits your needs. But yeah, that makes it really handy. It's really solid. Shouldn't break on you. Reliable pen holder. Finally, I just want to have a talk about thinking about your design of the robot and how it should go together. Trying to keep things modular is quite a good idea in this case. So that, as I see it, there's about 5 different areas of your robot that you want to think about. So your base comes into mind, your first joint, your mounting of your NXT, your second joint, and how you're going to attach your pen. So that'd be the 5 areas I'd focus on, and they should all be interchangeable with each other. So, for example, having your base and your first joint as one, and then being able to detach your second joint if it's prismatic and attach a revolute, that shouldn't matter. You shouldn't have to change the rest of your robot for that simple change. So this is a good example of a modular part. The pen should be able to, it's pretty universal. Same thing goes for the prismatic revolute joints that you're going to make later on. And we'll give you some examples of them later in the videos.